Okay, related rates problem that has an angle in it. So let's take a look at this. So you're given this scenario here that the beam is moving along this way, right? And then it kind of like flips around and starts over. So I always handle these the same way if I can. I say, okay, my first step, I'm going to relate the variables. That's theta, and this is x. So notice x is a variable. The tricky part about these is that the 275, you want to like plug that into your original equation. For example, it's going to be your tangent function. Theta is changing, it's a variable. Tangent is opposite over adjacent. You're going to be tempted to do this. This is not correct. Think about what's changing in this problem. The 525 is constant, does not change, but x is changing. They are asking about a particular moment in time when x is 275, but for us, x is changing, so it has to be a variable. So 275 is going to come into play later. Okay, that's the relationship between x and theta. And then my second step usually goes like this. I say, what do we want to find? Find what? Well, it tells you what is the speed of the beam? That's x. Okay, so, or rather the rate at which x is changing. So that's dx dt. So I need to find dx dt. Actually, my second step usually is, let me change that to step 3. I forgot my second step. And you don't really need to do this step process, but I write down what's given. So given is, and I'm running out of room, so I'll come up here, this weird rate of and this is the tricky part. There's a lot of times in these related rates, they all work the same, but there'll be like one part that you have to think about, or maybe do some kind of translation or adjustment to what's given so it fits your problem, okay? Or some kind of conversion, I guess I should say. So here's what's given. It's 5 revolutions per minute. Okay, that's d theta dt. Somewhere here. Focus beam light revolves 5 times each minute. Yeah. So that's your rate at which the angle is changing. All right. So let's see if we can make revolutions per minute. That doesn't usually help me. So let's go to my fourth step, which is to do the calculus. Take the derivative of both sides with respect to t. And then dx, the derivative of x is just dx dt. I don't need the chain rule. And it's 1 over 525, but I think it makes sense to put that over here. Multiply both sides by 525. Okay? Now the last step in all these is just to plug in everything you know. So what I need to know is the secant of theta. Remember, it's 525, I know that. Secant squared, don't let that mess you up. That's the secant of theta. I just need to find the secant of theta, which shouldn't be too bad if you know your trig. This is the tricky part. I can't plug in 5 here because the unit we're interested in should be radians. Okay, so I need the angle to be measured in radians, not revolutions. So we have to do a quick conversion, which actually isn't bad. 2 pi radians is 1 revolution. Okay, so to convert this, 5 revolutions would be 10 pi radians, and that's your trick there. All right, so that is 10 pi per minute. So our unit of time is minutes. So this should be something per minute, and it should be meters since that guy's measured in meters, and this ratio will be measured in meters over meters. Okay, so let's see. This would be 10 pi. I got to figure out what the secant of theta is. That's 10 pi. And then I'm almost done. Once I realize what this, and I know my answer should be in meters per minute. So that's good. Meters per minute, 10 pi radians per minute. And now I just need the secant of theta. So there's a couple ways to do that. Back to your picture. That's theta. And now we bring in that So they're asking about the moment in time when you're 275 meters that the beam is, that this distance is 275. So now I can bring that 275 in, and I just need to know that for this particular moment in time. And there's a couple ways to do this. You can figure out, I guess you could figure out what theta is, right? Because the tangent of theta is 275 over 525. And you can use your calculator to do the arctangent and get your radian measure. And then if you're using your calculator, you can get that radian measure, put it here, and just run it through your calculator and you're done. Or we can be a little more trig-centric, and I know the secant squared, which I'm trying to find, is 1 plus tangent squared. So I might want to use that. Since I already have the fraction, that might be useful. I'm going to need my calculator anyway, because that's a big number. That fraction should reduce since 5 will go into both of these. But what you should get, 1 plus that squared, well, the reduction would be 11 over 21. I worked it out. If you square both of those, you should get 121 over 441. Yet 1 plus 121 over 441. So that's 441 over 441. So you get 562 over 441. And that is secant squared theta. Secant squared theta. So now I can go back up, and I know that secant squared theta is 562 over 441. And this is 10 pi. And then I run that through, and I should get roughly 21,019 meters per minute.